Hello, we're looking at problem number 1 found on page 472 of your Geometry Part 2 textbook. This particular problem is using what's called the side splitter theorem. If you'll look back in the previous pages before this, it will kind of explain this in better detail. But very quickly, if two lines are parallel within a triangle, as you can see in the picture there, then the two sides can be set up as proportions to each other. In this case, we're comparing the PK to the KM in the same way we're going to compare LN to LM. And it's just they prove to you and try to show you that this theorem does work. So now problem number 1 is simply just using that particular theorem. So you can see that PK is x plus 1 is to 12 as x is to 9, which is x plus that is to 12 as x is to 9. Now, we call it cross product. I call it cross multiplication. If you simply cross the x plus 1 times 9, and then on the other side you're going to multiply the 12 times the x. You have to distribute that 9, so you're going to get 9x, you're going to get 9x plus 9 equals, and then the other side is 12 times x, which is 12x. Okay. Now, if I combine my x's together by taking that 9x and moving it over to this side or subtracting it over to that side, I end up with 3x. So 3x equals 9, divide both sides by 3, and x ends up being 3. So x here is 3. If you wanted to find the other one, it would be 3 plus 1 or 4 for this side right here. Okay. Now, let's look at the got it problems together. What is the value of A in the diagram at the right? And again, the key here is, notice that these two are parallel to each other. So I can set this up by saying A is to A plus 4 in the same way that 12 is to 18, because I'm comparing the short side to the longer side. And that only works because those two lines are parallel. If I cross multiply here, I'm going to get 18a for one side, and the other side I'm going to get 12a plus 48. Okay. Now, if I get my a's together, if I subtract that 12x over to this side, I end up with 6a equals 48. Divide both sides by 6, and a is going to be 8. So we end up with the a value being 8 on this particular problem. Okay. Now, the other one is just a thought question. If I had a triangle XYZ, and I'm just going to draw this. Oops, sorry about that. I don't know why this does this some of the time on my. I'm just going to draw a simple triangle X, Y, Z, and it goes ahead and says that RS joins this side right here. It doesn't really say where, but it does say that it is parallel. It's telling me that those are parallel to each other. So I'm going to put a little arrow here which represents parallel. And the question is, if the proportion that I set up, let me label that as RS. If I compare YR to RX, which is this side to this side, as in the same way that I compare YS to SZ, which is this side over here, which is what we do on all these problems. If that ends up being 1, then what must be true about RS? And for your proportion to end up being 1 or the same, remember the only way to get 1 is to multiply or have any number over any number, like 8 over 8 or 6 over 6 or 5 over 5. That's the only way to end up with getting 1. So that means to me that if I do get 1, it simply means that RS must be halfway up the side here, okay? Because that's the only way that this part and this part would be equal to this part and this part, is that they are, that literally is halfway up. So that's one of the things we can know about RS, that it is exactly halfway between X and Y and Z, okay? You will find out later as well that RS then is half the size of the bottom one when that happens, okay? Just thought you might need that for understanding. Best of luck.